So sorry for the delay. Again, let's continue the further. So I would like to explain 2, 3 terminology on this whiteboard. So then first one is in earlier days we were using compass and then chain survey where we are, let's say for example, this is an area, okay, on the ground. So what we are dividing this into triangles like this one, this is two, and this is another three, okay, and this is 4, 5, and 6, and 7. They're all triangle. Okay. Can you see the whiteboard? I think it's little puppet. So if the sides are A, B, C, D, E, F, G, okay, H, I, J, K, L, etc. etc. So this is a triangle, and then this is A, B, C. So area thereof is the S is equal to semi-perimeter, which is equal to A plus B plus C divided by 2, or you can say perimeter by 2. So perimeter is P by 2. Then the area of triangle would be, so then under root of S into S minus A into S minus B into S minus C. You might be getting this from the NET also. So this will be the area, and perimeter is A plus B plus C. And all that included, this length has been measured using chain, and all these angles are measured using compass. And all that vertical levels, they were supposed to use the Totti level, or thereby they could able to differentiate the altitude thereof. And having all this triangle known, so you can easily form the outer traverse, and thereby you can also reduce something in between. Suppose some buildings are there, structures are there. Again, that can be divided into further triangles, and thereby we can have this structure. So this is known as a method of triangulation. Okay. And whatever the traverse, the end of the traverse, if you are getting any gap thereof, so this needs to be closed. So this error will be distributed amongst all the internal and external angles, and thereby you are closing this. Or in short, you are dividing this error on equally distributing on all sides and angles. So this is known as a method of triangulation survey. And then I would like to elaborate that UTM. So nowadays that coordinates are very important because most of the time we are getting UTM coordinates. Okay. So Mr. Gautam Daya is advised to use red pen, so it would be more visible. Let's see. So now, see, this is the diameter of this diameter of Earth is higher on equator, and this is the prime meridian. So the diameter at prime meridian is less. In the top zone, north zone, one circle has been removed. Okay. The south pole, again, one circle has been removed. So if you will see the north pole, the south pole, so the top diametric view would be, you are not considering this area. Okay. And the angle which has been attributed to this particular circle is about 8 degree, and over here it is 10 degree. So out of 180 degree, 8 and 10, so this remaining angle is 164 degree. Now this has been divided into 20 equal parts. So this is 1, A, B, C, D, E, F, G, etc., etc. And then there is a zoning. So then there are radial curves. So what you are getting end of the day would be like it. I think let me clear this. So there are zoning of each zoning, and those zonings are like So these are all zone. These are all zone. Okay. Each zone has a dedicated name. Starting from the lower end, A and B are missing. Then from C to Y, X, up to X. From C to X, and again over here, I and O has been omitted. So there are 20 out of 26, 4 A, B, and YZ, and I and O. So there are 20 equal parts. So this is one part, this is two parts, this is three parts, four, likewise. And so far as this equator is concerned, so our Earth is having 360 degree, and each of them 6 degree. This part, one part is 6 degree. If I take center of the Earth and this one zone width is there, and this angle is 6 degree. So altogether there are 60 zones. 360 divided by 6, so there are 60 zones. And each has the approximate dimension at equator. So for example, say equator is the center of the Earth plane. Okay, so then this is the shape like this. This is a trapezoidal shape. Okay, it has been considered as a flag. So then this is a origin is not 0, 0. Some assumed values are there. And from over here, this length is about 666 kilometer for one zone. And this is about 900 kilometer for one zone. And this dimension will get reduced with the top meridian. What will happen over here? This dimension top may be reduced to 666 to reduce to 100 and I think 70 kilometer, and the lower side it is 117 kilometer. So the last one would be like this. Okay, 117 kilometer might be more than this, and again 900 kilometer. Then so this each zone is important, and your UTM coordinates are nothing but these are the coordinate with they are measured in meter. So from these whatever the datum value is there plus x value, so this is the coordinate. So this is x and this is y. So adding these two value, you will get the UTM coordinate of this particular point. So this is all about UTM coordinate. Let's go to the next. So then, what else is important? In surveying, if you are going for the linear survey for road, okay, or rail, or pipeline, or highways, etc. So what you are doing? If we are going for certain alignments, okay, and there are two terminology. One is right of way, and another is right of use, ROU. Right of way is like government is purchasing that land. Okay, so they are the owner of that land. Okay, and right of use. So it has been, they can see farmers can use their land for a particular thing. They can do something, they can't do something, but the approach and maintenance rights are there with the service provider. Might be a pipeline. They are most of the time they are going for a right of use, and for road, highway, railway, they are going for right of way. So here the linear survey comes in the picture, and how the parameters are important. Okay. Before going to LIDAR and all this thing, let me explain you. So if it is a linear survey, so say for example, you are planning for a road in a green field. Okay. So then you need to go for Reiki survey. You will refer Google survey map. Then you will try to draw certain alignments, possible alignments. Then you are moving across that alignment. Try to move out of that. You will find what are the hurdles thereof. And first you will go for the feasibility survey. Once you will find, yeah, fine, this is feasible, then you are going for the preliminary and detailed survey. So over here, if it is a pipeline, so let's say road. So road, what is important? So very first thing is the speed of the road. Okay, at what speed you would like to move your vehicles? If you were to design this road for 80 kilometer per hour, or some national highway or express highway for 100 or 120 kilometer per hour, so your radii has to be accordingly. The entire terrain will be divided into plain terrain, rolling terrain, and then hilly terrain. So in hilly terrain, there are a lot of restrictions. You cannot implement all the restriction which is given in plain terrain in hilly area. Reason is that in plain terrain, your radius of curvature for say 80 kilometer per hour, if it is 600 meter or 800 meter or 1200 meter, so then IRC is there for that. But then as your curve has been restricted for a certain to achieve that speed. So whenever you are going for the survey, so you have to ensure that then this angle of deflection is allowing your curvature. So for example, if I am drawing on a large scale, and if you are going for the very sharp curve like this, you are going for the flat curve like this, you are going for further flat curve like this. So whether this curve is feasible, so this delta and this curve is feasible or not, that is a correlate. So that you have to ensure for giving a right alignment, and you have to acquire land accordingly. One more thing is that see, suppose it is certain hurdle points are there. Over there, you are not getting your curvature. In that case, you have to restrict velocity. So it is a bottlenecking. So definitely, whatever the you are giving, so that bottlenecking will restrict speed, and thereby congestion of traffic would be there. So nowadays we are designing bullet train. So then bullet train is almost straight line, and if the curvature is there, that curve has to be in kilometers to accommodate that speed of the bullet train. Likewise, if you are going for express highway, so it's 120 kilo. Not only the curvature, then other than gradient is also important. Okay, then your rolling gradient should not be, if it is a ROB, should not be more than 1:50. Okay, even 1:60 is also preferred. So in hilly terrain, you might be going for up to 1:30, 20, and in certain small stretches might be 1:10 also. So the geometry of the road, speed of the vehicle, then gradient thereof, then another is the super elevation. See, if you are moving at a certain speed, what will happen? Then at speed, there is a centrifugal forces and centripetal forces. One is attracting towards center, and another is taking your vehicle away from the center. So those forces needs a certain slope of the road, cross, it's a camber, reverse cambering. So it is known as a super elevation, and it is applicable for road, rail, everywhere, all vehicle and everything which is moving on the surface of the earth. So then survey has to be done accordingly. If it is rail, then also your one track rail will be on a higher elevation compared to adjoining railway line, railway track. Reason is that to accommodate speed of the railway. And if you are not designing it properly, so your vehicle may overturn towards center or might be away from the center. Okay. So then here the survey is important. And definitely whenever you are going for giving for alignment or going for the final survey, so you are ensuring that all those curves are within ROW. It is not coming out of that, because the land acquisition is taking so much of time. So once if that the land acquisition has been done, and then somebody, the contractor, concessionaire is coming for construction, and there is problem in the data of the surveying and land acquisition, so it will take few more years, and all the taxpayer money used by government so will go into waste. And being a civil engineer, it is our prime responsibility to collect right data so as you can give right design to accommodate right execution. So this is all about linear survey, because then the levels are also equally important. Now, how levels nowadays to get more accuracy when you are moving total station. So what we are doing, if this is my possible alignment of the road, okay. So then with the use of DGPS, we are using time factor, we are giving more appropriate time. You are using control points. So these control points might be at a distance of say 5 kilometers each. So then these control points are having very high accuracy in X and Y direction, as your rover and DGPS system has been kept for few hours or few days also. So now we have to using total station, we are closing these towers. So thereby, whatever the inaccuracy is there, so that you are closing to the within a length of 5 kilometers. Similarly, this is another towers. So it is known as a traverse survey of using total station. The DGPS is also, you can work within that, but sometime to get more detail, total station survey is preferred over DGPS. Control point is okay. Then next comes is after traverse survey, the altitude, then height or level of that particular ground is very much important. So normally, again, the same way you are having levels has been reduced. So your what is the GTS benchmark? Okay, so worldwide GTS benchmark, okay, has been reduced from mean sea level. Okay, and from GTS benchmark, there is a permanent benchmark in the country. There are so many police station, post office, railway station. They do have a permanent benchmark. Okay, from permanent benchmark, we are reducing to temporary benchmark. Okay, and this we are might be using. Sometimes we are making survey using assuming that this pillar, top of pillar is 100 meter. I don't have right now data. I have made entire survey accordingly, and later I am checking that from permanent benchmark what I have reduced, and that level is 18 meter from mean sea level. So I need to add 18 meter in all that respective level, so I can reduce from local level to my GTS benchmark. There might be some accuracy or inaccuracy. It all depends on your type of equipment we are using. Now we are going to the next most important topic is other than DGPS. Nowadays there is a LIDAR survey. Okay. So in LIDAR survey, how we are getting survey done. Okay. So say for example, again it is a length or some projects are there in a zone. So this is the local side and this is the alignment of the road or rail, whatever. So say for example, this is the ROW which is required, okay, or strip which is required to collect all this data. For example, this is say 60 meter in length. So I should cover at least 30 meter on either side of my center line of my road to design a road, to prepare a DPR, detailed project report thereof. So what we will do, again, we will fix up some control point using DGPS system on top of the road at certain interval. Then say this is the terrain of the road in elevation. Here is my drone. Okay. So drone is having what kind of equipment is having? Drone is a flying machine. He is carrying certain weight. Okay. One is RTK. Okay. Then another is, this is for navigation. Another is a high resolution camera. Okay. And then one more is the LIDAR. It is LIDAR. So this is a laser measurement system. And this LIDAR is capable throwing 300,000 of beams. Okay, rays per second. Okay. So it measures 3,000 readings per second. So on the realistic ground, so this LIDAR, so then there are 300,000 of beams in 1 second. Now you can imagine how many readings would be there. So there are huge point cloud data along with high resolution photography, high resolution videography. So everything is transparent. Even you are getting reading. Normally surveying what we are asking for, okay, give us a level at 10 by 10 meter. Okay, or make a grid of 5 by 5 meter. Here, that grid has been reduced to 2 by 2 centimeter, 1.5 to 2 centimeter. That is hardly 1 by 1 inch. So here what happens, huge data are there. Out of that, we need to find out what is important data. Even if there is a tree, so for example, tree is there, and then there is a tree, there are the leaves, and then first ray will come, it will go back. And the other may pass through some hole, and then will pick ground. So it is known as a second return or third return, and thereby our software is also allowing us to remove all the tree and to see the strata or then surface underneath of that, or topography underneath of the tree can be also measured. So this drone is moving at a certain speed, and then it measures everything. Now processing across the country, people are making a survey very fast using LiDAR, but then they are taking huge time in processing. And in our company, our survey department team, so using high-end software which we have purchased from the developed country like USA and Italy, so they are capable to even process those data within no time. No time means other people might be taking 2-3 months, and we guys are used to within a week or two, we are in position to develop those data. Recently, Mr. Gautam Daya and that team has completed around 180 kilometer of length in 18 days only. So almost 10 kilometer a day is the average. And that everything comes. There is no need to go to site. Even the benefit to our end client is they can see what the land has been acquired, later any construction has been executed, or previously it was there. And without making any visit, they can penetrate into depth. They can see each and every tree, their plantation, their tree cutting, their jungle cutting, their all hurdles, everything. So nowadays, these are the LiDAR survey using drone. LiDAR survey can be also made using, we can fix on top of the four-wheeler, and then it is moving across the road. Thereby also you can measure. Basically, it is a scanning. Anything scanning using laser beam is all LiDAR survey. And we do have so many applications. So whenever you come across this kind of requirement, you can always contact Mr. Gautam Daya. So he will help you, either for maybe for client, maybe for our own project. So LiDAR survey is another thing that I would like to take up. Let's go to some basic thing. How in survey, what we are doing, one is a point. So point is a 0 unit, no dimension. Second is a line. It's line that is measured in length. Either we are using in millimeter, in meter, in kilometer. Okay. And the highest things in length is light year. Light year means if your light travels for 1 year period, and whatever the distance covered by that light is a light year. Similarly, if it is a plane, so it is measured, area measured in square millimeter, square meter, square kilometer, hectare. Hectare is like a 10,000 square meter equal to 1 hectare. You can say, to remember it easily, 100 by 100 meter grid. If your square of 100 by 100 meters, so that is a 10,000 square meter, and it is 1 hectare, approximately. Not approximately. Another approximate term is a biga. If you will see biga in Gujarat, so you will find 25,600 square feet equal to 1 biga. If you are going to Bihar, so would reduce to 18,000 square feet of biga. So biga is not an appropriate term. Yes, acre is appropriate term in terms of square feet. So it is about 42,000 square feet approximately. Or you can say 0.4 hectare. 40% of hectare is a acre. And in Gujarat, 25% of a hectare is a biga. So these are all dimensions to measure area. Then if you are measuring volume, so again it is cubic millimeter, cubic centimeter, cubic meter, cubic kilometer. Then in terms of if it is a liquid, you can convert that cubic centimeter, 1 cubic centimeter equal to 1 millimeter, 1,000 liter, 1,000 cubic centimeter is 1 liter, then kiloliter, megaliter, there are so many things. In British and US, then we are using gallon, and both the gallons are different. In the US gallon, it is approximately 4.4 liter, and if it is a British gallon, so might be 3.75 somewhere. So dimension measure is reducing in our metric system. It is a multiplication of 1,000. So for example, 1 meter. If you will reduce this dimension into millimeters, you have to divide that it by 1,000. So 1,000 millimeter equal to 1 meter. Again, if you are dividing 1 millimeter to 1,000 parts, then you are getting micromillimeter. So then 1,000 micron or you can micron or micromillimeter equal to 1 millimeter. If again you are dividing micron into further 1,000 parts, so then it is a nanometer. So 1 meter equal to 10 raised to 9. That is 1,000 into 1,000 into 1,000 nanometer. So this is on the lower side. If you are going on a higher side, so 1,000 meter equal to 1 kilometer, then you can always use like a data. No? So 1,000 byte is equal to 1 kilobyte. If again you are multiplying 1,000, so it is a megabyte. Then again multiply by 1,000, that is a gigabyte. Again multiply by 1,000, that is a terabyte. Okay, so these are the terms in metric system. Now, equipment we have seen, then there is a drone survey, then there is a total station, DGPS system, and then there is a level, there is an auto level, and associated prisms are there. Why? What is a prism? So your total station normally measure distance on a reflective surface. So yes, some of the area, every area is having some reflection. But if you need more precise thing, then you are keeping prism over here there. So you are getting 100% reflective surface, and the dimension measurement would be accurate. So we have seen the coordinate system, that is the geometric, then UTM, and the local coordinate. We have seen how the linear survey like railroad, pipeline, canal can be executed. And now next chapter is relevant to the volumetric. Now we are getting this information for planning, or once the planning has been executed, we need to reduce that planning on ground. Okay, so there are two types of survey. One is to collect data, and second, whatever we have prepared on drawing board or our AutoCAD or something, so that we need to reduce on ground. Okay, so that is another important application of the surveying. One has to be very specific. Otherwise, what happens if you are executing a tunnel from either side, and if you are not executing as per drawing or something mistakes are there, you will be never meeting other end of the tunnel. Okay, so all this technology is quite useful for execution of the mega size projects. Not only mega size, even if you are constructing a building, then also these are very much important. You have to line out of that particular foundation. You have to prepare 4 side pegs so as to ensure that those pegs are not been removed during earthwork. Because you have to, every time you have to take the center thereof for preparation of the foundation, column, beam, everything. You have to maintain that. So this is all about survey. Now, volume measurement. Now, this is one of the most important thing. If I am making survey for rail, road, anything, so I need to be on a higher elevation from flood. Might be a meter or 2 on highest flood level. If I am even designing a bridge, so my bridge has to be along with after the bottom of the girder, whatever the deck height is that, then there is a vertical clearance from highest flood level, and whatsoever other turbulences are that I need to add. So levels are very much important, and volumes are important. So if there is a embankment, so that embankment, whatsoever your ground profile, so ground profile is there, and your proposed levels are there, might be in topsoil. Yeah. So in earlier days, we are used to of making that chainage of 5 to 10 meter, and then that is we are working out area A0, A1, A2, and area at 5 meter, area at 10 meter, area at 15 meter, and then using average coordinate method and Simpson's rules, we are trying to work out the what will be the tentative quantity of earthwork on top of that profile. But nowadays, using all that state-of-art software like Terrain and other, we are also getting the ground profile, existing ground profile, and we can also propose on top of that in three-dimensional way, and we can straight away work out the volume thereof. So working out quantity is much more easier, but then you should know the basic fundamentals of survey. That is most important. Even might be most of you might be knowing the rules of 3, 4, 5. So reducing any point on ground. So there is a writing in a right angle triangle. Okay, in a right angle triangle. Say for example, I do have a baseline. Okay, and then I need to reduce this point. So I need to drop a perpendicular thereof. Okay, so now this is a perpendicular. This is my right angle triangle. If I need to reduce this point, what I will do if I do have this point? So from one side I will go 3 meter, on other side I will go 4 meter. In a way, because this will like this. In a way, so as I am getting 5 meter is my diagonal. Because if Pythagoras square of this is 25 equal to 9 plus 16. 9 is a square of 3, 4 is, 16 is a square of 4. So this is a 3, 4, 5. This we were using when we don't have equipment for line out. So it is a rule of 3, 4, 5. But this is the fundamentals. So whenever you are using any kind of survey, or if you would like to cross-check that, so these fundamentals are still helping us. And those are all basics, all that trigonometry and everything. So, yes, there are good equipments, state-of-art equipment. There are good software, but just don't depend on that. Whatever the outcome is there. So then being an engineer, you have to have the logic to cross-check that. How I will cross-check, how to verify. Because then if you are not making cross-check, you don't have the basic know-how. So big blunders can be happen. Okay. So don't depend everything on drawing or design, whatsoever you are getting. You ensure that yes, it is feasible on ground. And that feasibility, so that brings basic knowledge of surveying is very much important. So thank you very much. And I think I have divided that into 3 lessons. But due to lack of whiteboard and other things, I've tried to cover this 3 lecture into 2. And whatsoever your question session or question answer session, so I will, Mr. Gautam will give you one number and email ID, and you can always drop your query, or even not necessarily it has to be query. It is a knowledge, know-how sharing. So you can also put your know-how on that, so as we can distribute that amongst our other engineers, and thereby we can update our know-how, and that is the prime idea of this particular session. Thank you very much. Have a good day.